Good morning, students. Today we are going to start with the first topic in chemistry, grade 9, that is matter in our surroundings. The LO for the topic will be to comprehend the physical properties of matter. You all must have heard the term matter in the lower classes as well. In the lower classes, you define matter as anything that occupies space and that has mass. An addition to this definition is that can be felt by any of your five senses. So how can you define matter? Matter is anything that occupies space, that has mass, and that can be felt by any of your five senses. For example, if we talk about a wooden block, it has mass, it occupies space, and it can be felt. We can see it, we can touch and feel it. So it is a state of matter. Similarly, the air around us, it occupies space, it has mass, and it can be felt. So anything that is around you that occupies space, that has mass, and that can be felt by your senses, any of your five senses, you can define that thing as matter. Now we will move forward to the physical nature of matter. There are physical properties of matter and chemical properties of matter. In this chapter, we will discuss about the physical properties of matter or the physical nature of matter. What is matter made up of? The first thing here is that matter has particulate nature. This means that the matter is made up of particles. Matter is not continuous. It is not continuous like a wooden block. It is made up of very tiny small particles. Now how can we prove this? Through an activity. We will do a simple activity to show this, that matter is made up of particles. For this we need a glass of water. You can see here I have a glass of water. Now to this glass of water I will add a spoonful of salt. Now I'm gonna stir this water. You can see the salt particles are not visible in the glass of water anymore. They have dissolved within the water. So this proves that the particle is made up of matter. This shows that the particle of water had some spaces in between them, which have now been occupied by the salt particles. So the salt particles are not visible anymore. They have dissolved in this glass of water. You can see there are no salt particles in the water now. They have all dissolved in water. This is because the matter is made up of particles. It is not continuous. If it would have been continuous, then mixing up of two things or diffusion of two things would not have been possible. You would not have been able to mix anything with the other thing. This intermixing of two things is only possible because matter is made up of particles. The next thing is the particles of this matter are very tiny and minute. They are so tiny, they are so small that they cannot be seen with naked eye. They can even not be seen under a normal microscope also. They are small beyond your imagination. Everything around us is which occupies space, which has mass, and which can be felt by the five senses can be categorized as matter. Now, the things that we categorize as matter, they are all made up of particles. They are not continuous. The other thing, these particles are very, very tiny or very, very minute. They are so tiny that it is beyond your imagination. For this also, we have an activity to prove that these particles are very tiny. For this, I have some glasses here. I have a glass with red water. What I'm going to do is I will take a few drops of this red water and put it into the other glass which has clean water. What do you observe now? Do you see any change in the color of the next glass of water? Yes, the color of the next glass of water has also turned red, but the intensity of the color is low as compared to the first glass. So this shows that the particles are very tiny. Even if we add a few drops of water from one glass to the other glass, this will also bring a change in the color of the water. So this proves that the particles are very tiny. Even a small amount of water can bring change in the next glass. We can continue the activity by taking water from this glass, putting it into the next glass, then the next and the next one. This way it will continue, and it will be proved that the water changes its color because the particles of the red color that I have added in the first glass are very tiny, and as I move on adding it to the next glass, the intensity of the color, yes, it decreases, but it will surely bring a change in the color of the glass. Okay, the next thing now that we are going to jump on to is the characteristics of the particles. Till now we have studied that matter is made up of particles. Matter is not continuous. It is made up of very tiny small particles. Now, what are the characteristics of these particles? How do these particles behave? The particles have space in between them. What do we mean by this? We mean by this is that in the first experiment that we did was when we added salt to a glass of water, we saw that the salt particles mixed themselves with the water particles. Now, how is this intermixing possible? This intermixing is possible because the water particles had few spaces in between them, and when you added salt to it, those spaces were filled in by the salt particles. So this proves that every state of matter has few spaces in between them. The amount of these spaces vary from one state of matter to the other state of matter, which we will study in the next part of the chapter. See, this was the glass of water to which we had added salt. We cannot see the salt particles. This proves that the salt particles have taken up the spaces which were present in the water particles. This intermixing is responsible for all the smells that you feel, the fragrance that you can smell. This is because of the spaces in between the particles. You must have seen an incense stick at your home. A normal incense stick or a perfume bottle. You must be having a perfume bottle at your home. If you spray a perfume in one corner of the room and you're sitting in the other corner of the room, will you be able to smell the perfume in the other corner? Yes, you will be. Why is it possible? It is possible because air has spaces in between them, and when you open up the bottle of perfume, the perfume fills in the spaces in the air, and the smell of the perfume or the fragrance of the perfume, it reaches you. Similarly, when your mother cooks food in the kitchen and you're sitting in the room, you're able to smell what your mother is cooking in the kitchen. This is because of the spaces in between the particles. The particles have spaces in between them. When your mother cooks food, the smell takes up the spaces in the air, and through air that smell reaches you and you're able to smell it. The next characteristic of particles is that particles are in a continuous state of motion. What does this mean now? This means that the particles are not stationary. That means they are not at rest. They are always moving. The particles of a matter of all the states, whether it is solid, liquid or gases, they are always moving. They are never stationary or they never stop. They are always in a state of motion. They are always moving. You all know that whenever anything moves, for movement we need kinetic energy. So this means that the particles also have kinetic energy. For motion, we need kinetic energy. Motion is not possible without kinetic energy. So since the particles are moving, that means the particles also have kinetic energy. Now, how can we prove this? That the particles have kinetic energy and that the particles are moving. I just explained you the example of a perfume bottle. The same example applies here as well. When you open up a bottle of perfume, you are sitting in one corner of the room and your partner opens up a perfume bottle in the other corner of the room. You are able to smell the perfume sitting in the other corner. How is it possible? This is possible because the particles are moving. When your friend opens up the bottle of perfume, the perfume particles come out of the bottle, they intermix with the air particles move and they carry the smell to you. A similar experiment can also be done with an incense stick. This is an incense stick or an agarbatti that you usually call. This is an unburnt incense stick. I have not burnt it yet. So if I have to smell it, I have to go closer to it. I go closer, I bring this incense stick closer to my nose and I can easily smell it. Now, if I burn this incense stick in one corner of my room, will I be able to smell it in the other corner of the room? Yes, I will be able to smell it. How is that possible now? This is possible again due to the kinetic energy of the particles and due to the motion of the particles. Now this incense stick is burning. You sit anywhere around the house and you will be able to smell this incense stick. This is because of the kinetic energy now. There is a relationship between kinetic energy and temperature. Temperature and kinetic energy are directly proportional to each other. You can see a sign here. This sign stands for directly proportional. Directly proportional means the two terms that I am using here, if one term will increase, the other term will also increase. If one term will decrease, the other term will also decrease. In simple words, I can say, if the temperature is more, the kinetic energy will also be more. If the temperature is less, the kinetic energy will also be less. For example, like the incense stick. When the incense stick was not burning, we were not able to smell it very quickly.